So let's start by doing a Module 2 overview, just so you have a sort of general idea of where we're going in this module. And I'd really say there are actually kind of three big things that this module is about, but at the center of this is this idea of what are the sort of dynamics of things that we abstract to particles. And what I mean by things that we abstract to particles is just that we're talking about systems where we're interested in how the system as a whole moves, but not how the system rotates. So you might abstract a car to a particle, you might abstract a gymnast to a particle, and in all cases what you would be doing is thinking about that extended body and kind of taking that sort of extended body and compressing that extended body down to some point mass, and then asking the question, how does that point mass move? So if you were dealing with a gymnast doing a flip, this sort of level of dynamics would be a level of dynamics where you're interested only in how the center of mass of the gymnast moves, not in what angle the gymnast is at, or whether the gymnast's hands are sort of extended out or pulled in close to the body. So that's what we mean when we talk about dynamics of particles, is how do particle abstractions move, the particle abstraction. And in order to do that, there are a few things that we're going to talk about. One of the things we need to talk about a bit first is just the idea of forces. Right? Forces are the things that cause motion to change. We need to spend a little bit of time talking about where they come from, what the different types of forces are, and how we model forces. So there's sort of origins here, types, and modeling approaches for forces. Once we've talked about forces, we'll also spend a little bit of time talking about how particles react to forces. And so in particular, we'll talk about the thing that you've certainly seen before, the sort of differential equation, F equals ma. Most of you probably dealt with that differential equation back in Mod Sim, and most of you saw some versions of it in high school physics. We'll certainly try to expand that framing a little bit and get beyond the framing that's the sort of 1/2 AT squared type of framing that you tend to see a lot of in high school. But we're still going to be in this sort of chunk of things where we're talking about F equals ma. We'll be talking about how forces change the motion of particles when force is the only thing that's causing motion to change. And then finally we're going to go from F equals ma, and this is sort of the third big chunk of this module, to a more sophisticated framing that says not that F equals ma, but instead that F equals dp by dt. And dp by dt, p here is what's called momentum, right, which you of course have also probably encountered before. But the idea when we go from a framing that says F equals ma to F equals dp by dt is that in particular we're interested in cases where it's not just force that is causing motion to change, it's also mass flow across system boundaries, or momentum flow across system boundaries. So how do we deal with systems where the mass is changing? And those are really the three sort of big chunks we're going to be dealing with in this. How do we model forces? How do we talk about what the motion of particles is when subjected to forces? And then how do we talk about the motion of particles when it's not just forces that are acting, it's also flow of mass across the system boundary. So the sort of example that you might think about here is, how am I going to model some situation where I've got some particle that has a spring attached to it, maybe has drag acting on it, and so on and so forth. And so it's moving, it has drag acting, there's a spring that's acting, right? What's going on there? What are the tools that I need to do that? And then in this latter case where we're talking about momentum, how do I deal with, for example, a rocket that's flying through the air, right? So this is supposed to be a rocket. And when that rocket's flying through the air, not only is the rocket moving, but the rocket's mass is also changing. So it's not just its position and velocity that are changing in time, its mass is changing in time as well. So how do we think about the sort of definition of mass and the definition of momentum and those things changing in this particular case? Okay, so that's kind of the overall picture of where we're going in this module.